Hi, welcome to my video on solving trig equations, and this one is a linear one, the first one on linear. Solving trig equations, linear type. Recall, solve for a. 2a plus 3 equals a plus 4. Move the variables to the left and the numbers to the right. When you do, change the signs. A equals 1. Notice that the degree of a is 1 and 1, so this is a linear. This is a linear equation because it has a degree of 1. Solving for sine, so I wrote down 2a. So what I did is the same as saying that a is sine theta. So 2a is 2 sine theta plus 3 equals a is sine theta plus 4. So when I solve this for sine, that's the same as if I'm solving this equation here for a. We move the sine theta on the left side, and we move the constants on the right side. Sine changes to -1, 3 sine to -3, so 2 sine minus 1 sine is sine theta equals 1. So that's, when we're solving these trig equations which are linear, we will solve for either cos or sine right now. So without going further, I can keep solving this equation here because sine equals 1. I can look at the circle and say that sine is the y. So y is 1, so this is the point right here where sine is 1. Sine is the y, so that means theta is equal to 90 degrees if you're looking at the degrees from 0 to 360. So let's solve some for practice. Solve for theta from 0 less than equal to theta less than 360. So we're going from 0 to 360. And for the first example, cos a plus 2 equals 3. So cos theta equals 3 minus 2. Cos theta equals 1. So we draw the, remember we're working out on the unit circle whose radius is 1. So this point here is 1, 0. This point here is 0, 1. This point here is -1, 0. And this point is 0, -1. So cos is the x. So this is the initial, this is 0. So cos is 1, and that's at 0 degrees. And notice it's equal to 0 but not equal to 360. If I had an equal sign on a 360, then I would have to go 0, comma 360. But it's not equal to 360 because one rotation brings me back to 1, 0. Okay, now B example. So again, we got a sine, so we keep the sine theta on the left and move the number to the right. And we divide by 2, so sine theta equals a -1/2. And we check it out. Sine is negative, well, add sugar to coffee, or the casserole, CAST. Sine is the y, so y is positive in 1 and 2, so it's negative in 3 and 4. So we'll draw a diagram in quadrant 3, and we'll draw a diagram in, I'll do the two of them separately. And it's in quadrant 3, so we draw a terminal arm out perpendicular to the x-axis. And quadrant 4, we draw a terminal arm out perpendicular to the x-axis. And a half, sine is the y, so in this triangle, the y is a -1/2, and also the y here is a -1/2. But the x is √3/2 negative, and the x right here is √3/2 positive. Because that's a half, then this angle here is 30. Because that's a half, negative or positive, this reference angle is 30. So the reference angle for both of these is 30. So in the second the third quadrant, theta is 180 plus the reference angle. So it's 180 plus 30, so theta is 210 degrees. And in this one, you're in the fourth quadrant, it's 360 minus the reference angle. So it's 360 minus 30. 360 minus 30 is 330 degrees. And again, we took sine and plugged in 210 degrees, you get a negative 0.5. Plugged in 330, you get a negative 0.5. So we have to solve it for cos or sine theta. And we call them linear because degree is 1. And let's solve this one for 0 less than or equal to theta less than 360. And we have a bracket, so we have to multiply root 2 by cos. So that's root 2 cos theta. And positive times a negative is a negative. Root 2 times root 2 is root 4, which is 2, equals negative 3. So root 2 cos theta equals negative 3 plus 2. Move the minus 2 over to become a plus. Root 2 cos theta equals negative 1. And we divide by root 2 because we're solving it for cos theta. Root 2's cancel out, so cos theta. And we have a radical in the denominator, so we'll rationalize it by root 2 over root 2. So negative 1 times root 2 is negative root 2. Root 2 times root 2 is 2. And what quadrant are we in? Add sugar to coffee. Cos is negative, cos is the x, and cos is negative. Cos is positive in 1 and 4, so it's negative in 2 and 3. So we draw a diagram in quadrant 2, and we'll draw one in quadrant 3. Again, I'm doing them separate. Quadrant 2, terminal arm. Quadrant 3, terminal arm. Perpendicular goes to the x-axis. Okay, and we have root 2 over 2 for cos, so that's automatic 45 reference angle. 45 reference angle. Reference angle between terminal arm and the x-axis, between terminal arm and the x-axis. So theta here is, theta is this rotation. So its theta is 180 minus the reference angle. So it's 180 minus 45, which is 135 degrees. And theta here is in the third quadrant, so we go all the way around to here. So theta is 180 plus the reference angle. So it's 180 plus 45. So it's 225. So the two answers for this question is 135 and 225. So that's how we go about solving them. Again, they're linear. Notice the cos, degree of cos is 1 here. So that's you're solving for cos theta or sine theta, like solving for x. Practice. Pause the video and see if you can work these out. Again, the answers we're selecting from 0, less than or equal to theta, less than 360. So you can't have 360, but you can have a 0. So we remove the brackets. 4 times cos theta, 4 cos theta. 4 times negative 2 is negative 8. Negative 2 times 4 cos theta is negative 8 cos theta. Negative 2 times 4 is negative 8. And 4 cos theta plus 8 cos theta equals negative 8 plus 8. 12 theta equals 0. Divide by 12, that's a theta there. 12's cancel. So 12 theta is equal to 0. So we've got 0. So if you get a 0, 1, or negative 1, then you just got to draw the circle. And again, cos is the x. So the x is 0, so that happens. X is 0 right here, so it's 0, 1, and 0, negative 1. Remember, x right here is 1, y is 0, and x over here, x is negative 1, y is 0. So theta is, because x is 0, that's at a 90, and also right around here, 270. Again, we want the answers between 0 and 360, equal to 0, but not equal to 360. So there's the two answers. And number 2, we have to solve it for, notice we have a sign, so the sign goes on the left side, move 3 sign over to become negative, and move the negative root 3 to the right to become positive. So we get 5 signs, subtract 3 sign. Remember, the sign is like an x or a y, so 5y subtract 3y gives you 2 sine theta root 3, divide by 2, and 2's cancel, so sine theta equals root 3 over 2. And we want to check, where are we? Add sugar to coffee. Remember, just read all sine, tan, cos. So what you see is positive. Everything is positive in 1. Sine is positive in 2. Tan is positive in 3. Cos is positive in 4. And the reciprocals are also positive. So don't forget, you got sine, you got cosecant is positive. You got tan, cot is positive. You got cos, then secant is positive. So what you see here is positive. What you don't see is negative. So if sine is positive, that means cos and tan are negative, etc. So sine theta is the y, and it's positive. So sine is the y, and so sine is positive in 1 and 2. So we'll draw the diagram in each. So we'll draw them in terminal arm in quadrant 1 and a terminal arm in quadrant 2. Perpendicular goes to the x-axis. And sine is the y, so the y is root 3 over 2 for both of these diagrams, both quadrants. That's a half. Hypotenuse is 1. Hypotenuse is 1. This is a half, but it's negative in the second quadrant. And opposite the root 3 over 2 is a 60. Opposite to root 3 over 2 is a 60. So if that's a 60, this is a 30, and this is 30. But we want the reference angle. So the reference angle for both of these is 60. So theta in the first quadrant, theta is the reference angle, which is 60. And in the second quadrant, theta is this rotation here. Theta is 180 minus the reference angle. So that, let's move it up here. So theta is 180 minus the reference angle 60. So that's 120 degrees. So the two answers are 60 and 120. Notice we're between 0 and 360, but not equal to 0, but not equal to 360. Okay. Let's do some more. Again, practice. You can pause the video and work these out before I do. And 0 to 360 equals 0. So we have two fractions equal, so we cross multiply. So 3 times sine theta plus 2 equals 5 times sine theta plus 1. So we're cross multiplying. So we multiply by 3, we get 3 sine theta plus 6 equals 5 sine theta plus 5. And the sine thetas go to the left. 5 becomes a minus when we move it to the left. 5 sine theta. 5, 6 moves to the right, become a minus. So it's a negative 2 sine theta equals negative 1. Divide by negative 2. So sine theta equals 1/2. And again, let's check. Add sugar to coffee. Sine is positive, positive. Everything is positive in quadrant 1. Sine is positive in quadrant 2. So let's draw the diagram in quadrant 1. And we'll draw in quadrant 2. In quadrant 1, there's the terminal arm. In quadrant 2, there's the terminal arm perpendicular to the x-axis. Sine is the y, cos is the x. So in this triangle, the y is going up, so the y is 1/2. The y is going up 1/2. And this is the special triangle, that's 1. This is root 3 over 2. And this is 1. The hypotenuse, or the radius of the circle, is 1. And this is a negative root 3 over 2. But opposite a half is the angle of 30. Opposite 1/2, the angle is 30. So the reference angle is 30. So quadrant 1, the reference angle is equal to theta, which is 30 degrees. And this is quadrant 2. Quadrant 2 is this rotation here. Quadrant 1, theta is just this rotation right there, from here, which is 0 to here. And so theta in quadrant 2 is 180 minus the reference. So that's 180 minus 30. So the angle is 150 degrees. So 30 and 150 are the two angles that make this equation true. Number 4, again, positive it if you wish. We have brackets, so let's multiply root 3 by 2 root 3. So root 3 times 2 root 3. 2 times 1 is 2. Root 3 times root 3 is root 9, which is 3, so that becomes 6 cos theta. Root 3 times negative 1 is negative root 3. And we're multiplying a negative 1/2 by 4 cos theta. Negative 1/2 times 4 is negative 2 cos theta. Negative times a negative is a positive. 1/2 of 6 is 3, so that's 3 root 3. And we'll move 6 cos theta minus 2 cos theta. Or I could simplify all this side first and then move it. I have a choice. So I get, that's a negative 3 and a positive, negative. That's a positive becomes a negative. That's a negative becomes a positive. So that's 4 cos theta equals negative 2 root 3. Negative 3, add on 1 is negative 2, and they're like terms, so we get a root 3. And we divide by 4. We get cos theta, 4's cancel, and 2 into 2 goes once. So I get a negative root 3 over 2. 2 into 2 goes once, which is right there. 2 into 4 goes 2. And where are we? Add sugar to coffee. Cos is negative. Cos is positive in 1 and 4, negative in 2 and 3. So we're in quadrants 2 and quadrant 3. There we go. Quadrant 2, terminal arm. Quadrant 3, terminal arm perpendicular to the x-axis. And cos is the x, so negative root 3 over 2 is going for the x. Negative root 3 over 2 is going for the x in the triangle. So this is a 1, and the other side is 1/2. This is a 1 radius, or hypotenuse is 1, and the other side of this triangle is a 1/2, but is negative. So opposite 1/2 is a 30. Opposite to 1/2 is 30. So that means our reference angle for both of these is 30. And in this quadrant right here, theta is 180 minus the reference angle. So it's 180 minus 30 degrees, 150. And in this quadrant right here, which is quadrant 3, it's 180 plus the reference angle. 180 plus the 30, which is 210 degrees. So 150 and 210 is the value of theta that makes this equation true. And we have another one to do, number 5. And we notice we have fractions. And notice we're solving it to the nearest degree, which means all the rest of these, we had special triangles, 30, 60, 90. And we had also had where these points are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. But if we got to the nearest degree, that means the fraction coming out is not going to be a half, root 3 over 2, root 2 over 2. It's going to be, let's work it out. What do we do? What do I do when I have equation with fractions? I find the LCD. So the LCD, 8, 2, and 4, LCD is 8. So I multiply every one of these by 8. I'm going to take a shortcut. I'm going to multiply like this by 8. Multiply them all by 8. So 8 times 1/8, the 8 cancels, and I get sine theta. 8 times 1 is 8. That's theta there. A half of 8 is 4. 2 into 8 goes 4, so that's 4 sine theta. And 4 into 8 goes 2. 2 and 8 goes 4, just cancel that out. 4 and 8 goes 2, that gives me a plus 10. So the sine thetas go on the left. 4 sine theta becomes negative. The constants go on the right. Change the signs. So I get a negative 3, so that's a 1. Negative 3 sine theta equals 2. Divide by negative 3. And I get sine theta is negative 2/3. So notice the fraction is not a half, not root 3 over 2, not root 2 over 2, or 1 or 0. So the way we learned, we practice, is that we want this fraction to be positive. So let's look for the reference angle. The sine of the reference angle is 2/3. So if we take our calculator, we're looking for 2/3. So we take our calculator, we turn it on, and we go inverse sine of 2 division 3. And that gives us 41.8 degrees. So that means it's 42 degrees to the nearest. So the reference angle is 42 degrees. So now sine is negative, so we add sugar to coffee. Sine is negative, sine is positive in 1 and 2, so we're in 3 and 4. So we're in quadrant 3, and we're in quadrant 4. Draw the circle. Draw the circle. In quadrant 3, terminal arm perpendicular to the x-axis. Terminal arm in quadrant 4 is right here, perpendicular to the x-axis. And so our reference angle is 42 degrees. So we put 42 degrees in the corner between the terminal arm and the x-axis. So theta is this rotation right around here. So you can see that you're going 180 plus the 42. So theta is 180 plus the reference angle, which is 180 degrees plus the 42 degrees. So it's 222 degrees. And in the fourth quadrant, theta is this rotation all the way around here, right to here. So theta in the fourth quadrant is 360 minus the reference angle. So it's at 360, come back 42 degrees. And that gives 318 degrees. So if we check the sine of 222, you get a negative 0.66666. If you do 318 sine of 318, you get a negative 0.666. So that's solving some trig equations. Notice they're linear. Notice that's a degree of 1. There's nothing written here, so that's sine to the 1, like an x to the 1. or y to the 1. So they're linear. This is the first video on solving linear trig equations. And if you like my video, click the like button, the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.